We are going to continue our review of the pre-calculus material with our study of functions, and we're going to talk about parity, and then we're going to talk about polynomials in this video. So parity, really all the parity refers to is whether a function is even or odd. And just a reminder, graphically, it's even if we plot it, if we see that it is symmetric about the y-axis, meaning that we can fold it in half along the y-axis and get the same image on both sides. Algebraically, we actually have to do a little bit more work, but it's not too much more. We just have to substitute in minus x, and if after everything is said and done, if we get out the same function that we started with, then it'll be an even function. Now this example here, it should actually be to the fourth power. If we plug in minus x in either place, we'll end up with the same function, because if we take anything if we take a negative to an even power, it'll just end up being a positive one anyway. Now with an odd function, that one, we say it's symmetric about the origin, or we say it has a rotational symmetry. And this is when for the function here, if we can take it and spin it around 180 degrees and get the same thing, that'll be an example of an odd function. Algebraically, if we substitute in a minus x, we should be able to factor out that minus after we do everything. And now the examples that I chose for this worked out to be pretty nice. One general idea is if you are working with a polynomial and you have only even exponents, then it'll be an even function. If you have only odd exponents, it'll be an odd function. If you have mixed, it's going to be what we call neither. Okay. Now on to polynomials. Okay. So again, remember, polynomial is of anything of the form where we have this big long string of terms, and we say, well, n is a non-negative integer, which we actually call the degree of the polynomial, and a sub n, we call that the leading term, or the leading coefficient. A sub n, x sub x to the n power, that whole thing together, that's called our leading term. Okay, and the restrictions on these is that the coefficients here must all be real numbers, and this first one must not be 0, because otherwise it would not, or it would just be a reduction. Okay, some quick properties. Domain, always all real numbers for polynomials, and then we talked about leading term. Degree, we can find what we call the X-intercepts, or the zeros. You can also we're also going to be calling them the roots. If we set the entire polynomial equal to 0, meaning if we just set this side equal to 0 and solve, y-intercept, we now insert 0 for x and get out y. Essentially, the y-intercept's just our last term there without any x's in there. And then end behavior, this might be a little bit of review, a little bit foreign. So again, if this is our leading term here, if our leading coefficient, if our leading coefficient's positive and our degree is odd, that means as we go to the left it's going to decrease, and as we go to the right it's going to increase. And then if it's even, it'll increase on both sides if our leading coefficient's positive. If it's negative and our degree is odd, then we're going to increase as we go to the left, decrease as we go to the right. Okay, and then another way we can represent that, and similarly for the even case, another way we can represent that is to say as x goes to minus infinity, so that's the left side, our y value increases. As we go to the right, our y value decreases, goes to negative infinity. Okay, and running through a quick example here, so I have this function here. We have to determine the properties that are listed down here. Okay, so we're going to do that. And I have a hint here saying factor first. So if I factor this, well, let's see. I'm going to factor by grouping. Okay, so I'm going to, and for reasons that will become clear in a minute, I'm going to factor out a negative out of the first two terms. So I'll have a minus 1 plus x. Okay, and then out of these second two numbers, I'm going to factor out an x squared. So I'll factor out a positive x squared, and I'm left with, let's see, I'm going to have a minus 1 plus x. Okay. Now again, the reason I did that minus was or factor out that minus was so that I had both terms here. And if you don't have that immediately, you'll get it in another step or so. Okay. And continuing, I factor out that minus 1 plus x. Okay, and I'm left with, now this is actually a minus 1 out front. So minus 1 plus x squared. Okay, and I can take this a step further and factor this down to minus 1 plus x, and then I'll have, I'm going to say this is x minus 1, just rewrite it, and then x plus 1. It's a difference of squares. And so I can condense that all into x minus 1, and I have 2 of those, so I'm going to have an exponent of 2, and then x plus 1. Okay. So that's as far as I can factor it down. Once you get to binomials or a polynomial of degree 1, that's usually as far as you can factor. Okay, so degree, I can actually answer that without even doing this. I look for the highest appearing exponent. That ends up being 3. Now a common mistake is to say, okay, well it's 3 plus 2 plus 1 plus 0. That is only if you have multiplication signs in between. We are looking for the single term, and a term is separated by an addition or a subtraction sign. The leading coefficient. So I look at my leading term, the degree with the term with the highest degree. Coefficient is just 1. Okay, and so now I go up to my table. Okay, my leading coefficient was positive, my n was odd, so my n behavior is going to decrease as I go to the left and increase as I go to the right. Okay, X-intercepts. Okay, so this is, we need to set this entire thing equal to 0. Essentially, set this equal to 0 and solve. Okay, well, the two things that make this 0 are going to be x is equal to 1 and x from this first term, or x is going to equal minus 1. Okay, one other thing we should technically say here, that since we have two zeros at 1, I should say this is multiplicity. I'm just going to write mult 2, okay, because that's the number of zeros I have that are 1. Lastly, y-intercept. Essentially, put in zeros for x's, and I'm going to get out y is going to equal to just 1. Okay, and so really I should represent this as 0, 1 in coordinate form. Okay, and so that's just a brief review of polynomials. Stay tuned for examples of more functions.